Okay, now you lucky people, dig out that Venn diagram from your bag because now you get the chance to use it. I want you to list all the similarities and differences between gravitational and electric fields. By the end of this session, we should know the similarities between gravitational and electric fields. We should be able to identify the similarities between the formula for both types of field and explain the sign conventions for both types of fields and the importance of understanding that gravity is always attractive and electric fields can be either attractive or repulsive. And we should understand that the main area of difference in these fields occurs inside a mass or a charged hollow sphere. Here are the main similarities and differences between electric and gravitational fields. The holy grail of physics is to find and understand the rules which govern the universe. So nothing complicated then. Many physicists believe that the four fundamental forces of nature are actually just different parts of one single basic universal force. The four fundamental forces are electric force, gravitational force, strong nuclear force, and the weak nuclear force. And you may be surprised to know that the most mysterious of these is actually gravity. As we've covered throughout this section, we know that gravitational and electric forces have a great deal in common and a few important differences. The formula for gravitational and electric fields are shown here. As we discussed earlier in the section, the graphs for potential and field strength for each field looks like this. It's important that you are familiar with these graphs and you understand that if you are asked to sketch the graphs, you can clearly show that the field strength falls away far more quickly with distance than the potential does. You should also remember that the gravitational potential has a negative answer, so the graph should be plotted below the axis like so. The relationship is V is directly proportional to minus 1 over R. Similarly, the potential around a negative charge will be negative because of the sign convention. So again, the graph should look like this and be below the axis like so. Right, check all the information in your Venn diagram. Is it complete? If you're sure it is, then swap with another student and check to see if they have covered all the information in this section. And finally, let's try that word association that we started off the section with. You should have kept the answers you gave the first time around, and you should be able to repeat this exercise to see if you get any different answers. Thanks for your time.